Welcome to Homework Lib.
Hi, so in this case what is going to happen is that a rock is being thrown from a height equal to h at a certain velocity b naught, and we want to know what is, it is thrown horizontally, so there is only initial velocity on the x-axis, and we want to know what is the kinetic energy when it hits the ground. So the first thing to notice is that this is the same as a parabolic shot, but the difference is that we have an initial height. So the equations of motion for x and y are going to be the following. Of x as a function of t is equal to x0, which is equal to 0, times b naught t, and we're not going to have any acceleration on x, right? Next up, for the y position as a function of t, it's going to be equal to y naught, which is h. We don't have any initial velocity on y, so that term is equal to 0, minus 1/2 of gravity times t squared. So the height it is going to decrease as a function of time, right? With the acceleration of gravity. So what we want to know is just the kinetic energy. So by conservation of energy, at this point, what I have is kin- kinetic energy on x and potential energy. Since energy needs to be conserved, and as you can see, there's not going to be any acceleration on x, what is going to happen is that the velocity on x as a function of time is going to be equal to b naught. It is constant. So the kinetic energy when it hits the ground is going to be equal to mgh coming from the potential energy that the rock had up here that is going to transform into kinetic energy completely, plus the initial kinetic energy that we had on the x direction. So 1/2 of mass b naught squared. So this is going to be our answer for this problem, which corresponds to answer D. That would be all. Thank you very much and have a good one.